All right, today we're going to talk about something that sometimes garners some differences of opinions, to say the least, and that is whether or not specifications matter, whether or not you should look at them seriously in terms of selecting a pair of speakers, an audio amplifier, really any piece of equipment. And what I've got here is actually a frequency response graph from a pair of speakers as they reproduce sound in a given space. And this is actually a pair of omnipolar speakers called the Schmidt Ubiquitous version 1s. And we essentially put a microphone in a room. We play a series of test tones or sweeps of different frequencies. The microphone records those, it puts them on computer software, and then we can look at it. Now on this side of things, and we'll go a little bit deeper into this later, this is the bass side of things. This line represents about 45 hertz, and we start to see the bass dropping off at this point. It's not that it doesn't produce bass below 45 hertz, but there is a significant decrease in output, so it's going to be less audible. And on the high frequency side of things, somewhere in this area here, as we start getting around 17,000 hertz up to 20,000, we start to see a drop again in frequency output. It produces those frequencies, but just not at the same output as it would maybe in these mid-band frequencies. So does this matter, first and foremost? What does it mean? And how does the room affect what we're actually seeing here on the graph? Okay, now I'd like to share with you two different charts. We're going to start with the one over here on the right. So we can see a much simpler frequency response chart starting from 20 hertz, working its way up to 400 hertz. Now this is computer software that allows a speaker builder, a designer, a manufacturer to predict the performance of a pair of speakers without having to put them in an anechoic chamber. So what's done is you install the kind of parameters of the speakers into the program, which would also include the cabinet, the dimensions of the cabinet, the volume of the cabinet, the number of ports, the diameter of the ports, and the program kind of spits out the chart of what you could expect from the speaker. And if you recall the earlier graph I put up where we ran the sweep in the room and we mic'd it at about 45 hertz, it said that we would have a drop off, or I was saying there was a noticeable drop off in bass energy. And certainly looks like that's predicted here on that chart as well. In fact, the program says somewhere at about 50 hertz, so if we kind of move across at 50 hertz, we probably end up somewhere over here. There is a 3 dB drop in normal bass output. Now we call that the F3. Now whether or not you can hear 3 dBs drop in bass energy, we'll talk about that in a moment. But you can see to the right side here, a fairly kind of smooth and neutral response, otherwise up to 400 hertz. Now here on the left, we've got a frequency response chart with a whole bunch of different sweeps that were run of the same speakers. In fact, this is the same chart that we put up earlier up here. At least one of these lines is on the chart, but what was changed was the axis here on the left, the decibel output. And that kind of changes the visual representation of the graph. It makes it a little more obvious to look at any sort of abnormalities, so on and so forth, actually to determine whether or not there's a problem, there's an abnormality. And in this case, I'm going to zoom in right over here on the speaker because we haven't changed the positioning of the speakers in the room. We haven't towed them in, we haven't moved them forward, we have not turned up the gain on the amplifier. What we have done is run 5 separate sweeps and got 5 different results. Now the question would be why? Now I'm going to exclude for a moment the red line and the orange line because in these two instances we used an attenuator that we have to control the speaker, particularly the tweeter on the speaker. And on the other 3 graphs, the green, purple, and blue, there was no adjustments whatsoever. The only thing that did change is we changed the shape of the diffractor over top of the speaker from the circular orb to the cone diffractor that's designed like an exponential cone. And what we found on average was over a 2 dB gain across the board on all frequencies when we put that diffractor in place. So right here, this is the orb, and this green line up here would be the cone diffractor. That's actually about a 7 dB gain just by changing the shape over top of the speaker, which certainly goes to prove that when the speaker interacts with its surroundings, whether it's a diffractor or whether it's the room, we are going to get a different response. So no two rooms are going to sound the same. And in fact, in some of these instances here, we also change the height of the diffractor, so the distance from the shape to the speaker. Certainly, again, it goes to show that room acoustics would make a difference here, without a doubt.
In fact, the room will cause, well, mid and high frequencies to bounce around kind of like billiards balls on a table until they eventually run out of energy. Bass is affected differently by the room and room acoustics. Imagine, for example, this beer bottle. If you were to blow over the top of it, you would get a reverberation, a tone. And that's kind of what happens in a room. Certain bass frequencies are actually reinforced, whereas others are canceled out. So you can see the room plays a huge role in this. Now let's conclude on talking about interpreting specs.
Now I want to show you two different graphs. I think this is interesting. So on the left-hand side, this is the output in decibel. This is actually a 24 dB scale. So the difference from the bottom in decibels to the top is 24 dB. And then we have our frequency responses across the bottom here, right up to 20,000 hertz. The separation between these points is what we call the octave. Now, when we look at this chart, we see relatively a jagged edge chart. It doesn't look very neutral. We've kind of been trained to think that a straight line is really what we want to see in terms of speaker performance. All right, so now we have a second chart, speaker B, 20 hertz, all the way up to 20,000 hertz. And on first glance, one would say this looks like a smoother frequency response, probably a more neutral pair of speakers. And if I was to pick one or the other, I'm taking this pair. Now, it may surprise you, it may not, but this is the exact same pair of speakers, the exact same data. All that has changed is the visual representation by changing this axis. This is now 120 dB scale, negative 30 dB, up to 90 dB. So a manufacturer can essentially take data and by changing the visual representation of that data can make it look more appealing. There's also other techniques which we call smoothing factors. We could be using a 1/3 octave scale or a 1/12 octave scale. If we use a 1/3 scale, things will look a lot smoother, whereas 1/12 will look a little more detailed. So when we have a chart like this, one thing is the chart. The second thing is actually trying to understand the chart to make sense of it.
Audioholic said that measurements are a great starting point to understand how a speaker performs in a given room, but it cannot be a replacement for controlled listening tests to do the final voicing of a product.
And what it goes to prove is that a speaker is very much affected by its surroundings. In fact, unless you were listening to a pair of speakers in an anechoic chamber, what you're really hearing is the way the speakers interact with your room. This is why speakers never sound the same in two different places, whether it's your friend's living room or whether it's the stereo shop or whether it's back at your house. And I've proven this to myself numerous times, in particular with these speakers, testing them in a couple different places and seeing different frequency responses and the changes when subtle things were done like room treatment on a wall. So your surroundings are so important. Overall, the positioning of the speakers, is part of that to what you're actually hearing. Now, you may have an acoustically dead room with lots of furnishings, carpets, pictures on the walls, or you may have a really acoustically active room where there's hard surfaces, and you'll see a change in the frequency responses. You might see rolled off high frequencies in a more dead room versus kind of higher frequency response in terms of gain in dB with a more active room. So are the measurements important? Well, they are. They're important particularly for the manufacturer to be able to have a guideline to design speakers and to see if they're performing at all like what the computer software said they should or would. Now, a lot of manufacturers don't share these specific specs with you. They'll just share 40 hertz to 20,000 kilohertz, but that's probably more the response of the speaker itself, the component, the driver from the original manufacturer, and less of everything in the box in a given space. I think a lot of manufacturers are probably scared to share that because unless you really know how to interpret it, people kind of get scared off by a frequency response that's not perfectly straight. Now you can change how straight the response looks by just changing the actual grid on the graph or by using smoothing factors, which will make things look not as jagged and ragged, but that's just kind of playing with numbers. So how can we treat our rooms, and do we need room treatment? Well, I mean, that's a big discussion. Playing with, again, the positioning of the speakers is where I would start, and then secondary, paying attention to your surroundings. You can even walk through the room with, you've probably heard this before, clap and kind of listen for the echo in the room, which will give you an idea of whether the room is active or dead. And you may be able to try different treatments to see how the sound changes. Now, wouldn't we all love a microphone and the software to run a sweep through our speakers and adjust and tweak? Might not be very practical. So specs, yes, they have a place, but ultimately what really matters is how it sounds to you in your room. Hope you enjoyed today's episode on The Vibe, and we'll be sure to see you next time. Don't forget, like and subscribe.